All right, today's lesson is over subtracting rational numbers. So to start with, I've got some questions like the ones on our test for chapter 1 that we just went over that would have you practice the skill of changing a subtraction problem into an addition problem. Because if we can write it as an addition problem, we can use join forces or go to war. So to do that, I'm going to use keep, change, opposite. So we'll start with Gage there in the back. Gage, if I use keep, change, opposite, tell me what this problem is going to rewrite to. That's right. Gage, do we go to war or join forces on this one? Yep. We're going to go to war. The negative army wins by 8. Example B. Negative 6 minus 15. Andrea, what does negative 6 minus 15 rewrite to? That is correct. Keep, change, opposite. Excellent. Andrea, is this a join forces or go to war problem? That's right. When we join forces, they keep the same team, and that's going to make negative 21. It's not two negatives make a positive because I'm not multiplying them. I am adding them. All right, so remember those rules. Maddox, the next one is negative 18 minus negative 9. Can you use keep, change, opposite to tell me what this would be as an addition problem? That's right. Maddox, do I join forces or go to war? I'm going to war. And the negative army is going to win by, whoops, 9. There we go. Yeah, subtract, right? Anytime I go to war, I'm subtracting to figure out how much the winning team won by. Example D, Hunter, rewrite this as an addition problem for me. Good. We're going to go to join forces or go to war here? Yeah, who wins? Nobody. What do I put? 0. Nobody wins, put a 0. It's the only number that doesn't take sides. Example E. Alexis, rewrite this as an addition problem. Yep. Keep, change, opposite. Nice job. Negative 13 plus negative 17. Alexis, am I joining forces or going to war? Joining forces, they'll stay negatives and they'll make negative 30. Man, I'll tell you what, after working with fractions and decimals, it sure makes integers seem easy, doesn't it? Joe?
Isn't that positive 17?
Well, let me reread it. Let me read it. Original problem too. Negative 13 minus 17. Did I say negative 13 minus negative 17?
Oh.
She rewrote it that way because you have to take the opposite. So this is my subtraction sign, or my subtraction sign. That gets changed to addition. The 17 was positive because that was just a subtraction sign. It changes to negative. Good question. And the last one, Michael, can you tell me what negative 12 minus negative 30 rewrites to?
Negative 12 plus 30.
Good. We're going to join forces or go to war? Yeah, we're going to war. And who wins? Positives or negatives? Yep. And they're going to win by 18. I subtract and I get 18 there. I could pretty much stop right here and say, all right, now get started on the homework. Now I won't be that mean because I want to give you some examples. But obviously we're not working with integers today. We're working with rational numbers. The only thing that we're going to do differently than what we did on the 2.2 homework that you guys just turned in is one thing. We're going to take the problems that are written as subtraction. You okay back there, Gage? Okay. We're going to take the problems that are written as subtraction and we're going to use keep, change, opposite to change them into addition. And once we've changed them into addition, we're pretty much doing 2.2 all over again. Adding rational numbers, join forces, go to war. Okay. So remember, to subtract numbers, you add the opposite of that second number. Yeah, not the opposite of the first number. I've seen people take the opposite of the first number. It is keep, change, opposite. Keep the first number. Change it to addition, opposite of the second one. So let's go and practice some decimals. Okay. The decimals, I'll be honest, when we're adding or subtracting are the easiest ones to do. I just have to, as we mentioned on Tuesday, line up the decimals. That's right. Okay. So how is this problem any different from the one we did on Tuesday? Well, it's written as a subtraction problem, not as an addition problem. So I'm going to use keep, change, opposite. Addison, can you tell me what this problem would be if I rewrote it as an addition problem? Using keep, change, opposite. Keep the first number. What's the first number? Is it really 12.63 or is there something in front of it? There you go. So we're going to keep that 12.63. We're going to change the subtraction sign to addition. And then we're going to take the opposite of this 5.627 to make it, that's right, negative 5.627. That is the only thing we're doing differently on tonight's homework versus Tuesday's homework. Now, I'm going to take my larger number. Ignore the negatives when you do this. Larger number is the 12.63. Line it up with the 5.627. Line those decimals up and fill in with any extra zeros that you need to, like the one above the 7. Now, Calvin, Addison's rewritten this for us. Is this a join forces or go to war problem? It is a join forces. Okay, how do you know? That's right. They're on the same team. So that join forces means we're going to add them together. And when they join forces, they don't switch teams. So I know my answer is going to remain negative. So I can go ahead and put that down there. So when I rewrite my work, I don't need to put any of the negatives in the work because I know I'm going to subtract because I'm going to war. Or sorry, I said that wrong. I'm going to add because I'm joining forces. And I know it's going to be negative because they keep that same team that they're on. So I'm going to add. Aaron, what's 0 plus 7? 3 plus 2? 6 plus 6? Carry the 1. 1 plus 2 plus 5? 8. Don't forget to put your decimal down between there as you're doing that. And then 1 plus nothing. So my answer is negative 18.257. You got it wrong? What'd you do wrong? Yeah, I double check. I mean, I don't know without looking at it. It could have had the numbers in the where the decimals lined up. You know the right numbers are written down. Okay. Screenshot it, and I'll look at it after class. Okay. Example B. I'm going to rewrite this. Maybe on. What does this rewrite to? 8.91. That's right. And I'm actually getting lazier as I go. Just going to do this. That's fine. It's an addition problem now, right? Okay. The larger number needs to be written on top every time. The smaller number needs to be written on bottom every time. Line up your decimal points every time. This is what I got. Now I don't know if I'm adding or subtracting yet. So maybe on. Is this a join forces or go to war problem? Yes, because that second number is now negative. We have different signs. And so we're going to go to war. And then which army is going to win? Maybe on the positive 4.5 or the negative 8.91? There you go. My negatives and my answer. I've already checked that. Now I just have to do the work. Somebody tell me what 1 minus 0 is. 1. 9 minus 5? 4. Decimal point. 8 minus 4? Yep. Negative 4.41. That one a little bit better. One more. Decimal one. How far apart is negative 12.31 and negative 7.97 on a number line? Now, if I ask you how far apart they are, I want you to think about this. I know those are decimals, so let's make it a little bit simpler. How far apart is the number 6 from the number 10? Right? 4. How'd you get 4? You subtracted them. Anytime I want to find the distance between two numbers, I just subtract them. Can distance be negative? No, that's why absolute value exists, right? distance can't, so I noticed that Frank didn't say that they were negative 4 units away. It doesn't matter what side of the number line you're on. If I take a left out of the drive, I'm not going negative just because I'm going to the left, right? I'm still just traveling a certain distance that way or a certain distance this way, north, south, east, west, doesn't matter. It's always going to be positive. So this is going to give us a positive answer. I'm going to take my larger number, 12.31. Frank said we're going to subtract to figure out how far apart they are, 7.97. And I'm going to use my integer rules now. Can I do 1 minus 7? Nope. So I call that borrowing. Can I do 10 minus 7? Yep. What is it? Okay. Can't do 2 minus 9, so I'm going to borrow that, but I can do 12 minus 9. What's 12 minus 9? 1 person knows. It's good. Better than 0 people, I guess. Joe, I borrow from the 1 and make this 11 minus 7. What's that? 4. And I get 4.33. Those two numbers are only 4.33 units apart. Now that I've done decimals, let's switch over to fractions. We don't like fractions as much when we're adding or subtracting, especially. You don't? You do? You like them? Okay. I've got the new rule here. Rewrite them as addition. That's new. I mean, it's not new. You guys have done it, but we didn't do it yesterday. We didn't do it yesterday or Tuesday when we did those. Everything else we did. We found common denominators. We changed the numerators if we ended up changing the denominator, and we added or subtracted depending on whether we had same signs or different signs. So let's jump right into this one. 2/5 minus 7/15. I'm going to rewrite it as an addition problem. Izzy, how do I rewrite 2/5 minus 7/15 as an addition problem using keep change opposite? That's keep change flip. I want keep change opposite. So is there we go. Yes, got it. Okay, that was easy enough. Hey, boom. Now it's an addition problem. Perfect. I want a common denominator. I need the first, Elena, the first multiple of 5. That's also a multiple of 15. Well, it can't be big. It can't be smaller than the biggest one I have is 15. So it can't be smaller than that. Just let me ask you, does 5 go into 15? Yes. So I can use 15 as a common denominator then. 5 is the, 15 is the first multiple of 15, and it's the third, thank you, multiple of 5. So what I'm writing down here, it's kind of what I'm doing in my head. I mean, you don't have to write that down if you don't want to. 15 is going to be our common denominator. So since 15 is the third multiple of 5, we're going to times that by 3 to get our 15. What's 2 times 3? 6. So this just became 6/15. The second fraction never changed at all. So I keep it as negative 7/15. Is this a join forces or go to war problem? We're going to go to war. Who wins? The negatives by how many? 1. There we go. There's my answer. That wasn't so bad. Oh my goodness. These things here drive me crazy. I'm trying to use Notability. Quit emailing me, everyone. Everyone. Literally everyone. All righty, some mixed numbers. And I told you on Tuesday, I'd show you a way to convert these to, or leave these as mixed numbers instead of converting them to improper fractions. I don't have time today, so I'll just have to show you tomorrow how to do that if you're interested. But for today, I'll show you what your teachers did last year. Your teachers last year had you convert these to improper fractions. So let's do that. What is 8 times 5 plus 3? Okay, 43/8. Don't forget that it's a negative 43/8 because that fraction was negative. Now I'm going to try to do 2 steps in one here. And here's the 2 steps I'm going to try to do. I'm going to try to convert this to an addition problem while also converting this to an improper fraction. So I'm supposed to use keep, change, opposite. What's the opposite of 2 1/3? Negative 2 1/3. So I know it's going to be negative. And while I'm doing that, what's 3 times 2? 6 plus 1 is 7. So I'm going to change that to a negative 7/3. Did I lose everyone on those 2 steps? Keep, change, opposite. We converted them to improper fractions at the same time as well at the same time. So instead of saying minus 7/3, now it says plus negative 7/3. Keep, change, opposite. Now it's an addition problem. Do I have a common denominator? I don't, not right now. What would it be? 24 is the first multiple of 8. That's also going to be a multiple of 3. To get 24, I have to do 8 times 3. This is why I don't like improper fractions, because the top numbers get really, really big. But don't fret. We can do this probably using mental math. What is 3 times 40?
120.
That's right. 120. He's just doing 3 times 4, adding a 0. All right. 120. What's 3 times 3? And what's 120 combined with 9? Yes, and it was negative. Probably can use mental math on this one too. What's 7 times 8?
56.
56, and it's also negative. So are we going to be joining forces or going to war? We're joining, yes. We get to add. So I got to do 129 plus 56. I don't know what that is, so I go off to the side. What's 9 plus 6? 1 at a time. 15. What's 1 plus 2 plus 5? 8. What's 1 plus nothing? Okay. When you join forces, do you flip teams? No, you stay on the same team. So it's going to be a negative 185 over 24. And that's not going to reduce because I use the lowest common denominator. And a lot of times when I use the least common denominator, you don't have to reduce at all. So it's worth finding out what it is. It's worth it. Can I ask that your masks are up? I see a lot of people's mouths or complete everything back there. Go. One more today. You guys will be caught up with periods 1 and 2. And that leaves us with 2 homework questions or 2 notes questions that we'll do tomorrow. And example D would be a good example of me showing you how to keep these as mixed numbers, because I promised you I'd show you that, right? So we'll say that example D, and we'll do 1 with decimals when we come back. But we're going to do example C right now and be done. So example C, I need someone to explain to me how to turn 4 into a fraction. Izzy? That's exactly right. Any whole number or integer like 4 can be turned into a fraction by putting it over 1. Now I'm supposed to use keep, change, opposite, which means this is actually just going to be 4 over 1 plus positive 6 3/4. But what's 6 3/4 as an improper fraction? That's the question. What's 6 times 4? 24 plus 3. Now, do I have common denominators right now? I don't, but I need to. What could I multiply 1 by to get to 4? Yeah, that's easy. Multiply this fraction by 4 over 4, and that'll line up the 4s up on bottom. So 1 times 4 is 4. What's 4 times 4? Okay. Does everyone agree that 16 divided by 4 is still 4? I never really changed anything, right? Okay. Now, if I don't change the second fraction's denominator, I don't need to change that fraction's numerator, so it's going to be 27. And am I going to join forces or go to war? Join forces. And there's not even any negatives, so they're going to join and just get more positive. So go off to the side. 6 plus 7 is, carry the 1. 1 plus 1 plus 2. And aren't you glad that you don't have to convert them into mixed numbers this year? Isn't that nice? Just leave it as improper and walk away. Walk away from it and say, you know what, I've done enough. I'm out. Okay, as long as it's reduced. Don't give me 86 over 8. Give me 43 over 4. That's reduced, I'll take it. Okay? You guys are dismissed. Tomorrow we'll go over your e-learning worksheets. Let me know if you have questions. What if you're doing it if you're at home and you have a question? Email me. Yeah, don't just sit there and stare at it. Email me. Sounds good. Appreciate it. And hey, Izzy,